Hey guys, this is SyedaZaidi, and today I'm going to be talking about lesson 9.1, chapter 9 in pre-calculus. So this topic is mostly about, it's called sequence and series. Now sequences are a amount of numbers. So like example, like 1, 2, 3, 4, 5, 6, and then so on. You know what I mean? Just infinity, basically. Well, that would be called infinite sequence, but most of the time most of the time the equations are, like example 5, 4, 6, 7, and then it just stops. So the infinite sequence is where it just goes infinitely, like just 1 through like a trillion. It just keeps on going, you know. There's also fractions that involve infinite sequence too, like fractions, whole numbers, negative numbers, decimals, all those kind of like rational numbers, even square roots if you would want to add that. All those things involve in basically in the sequences. So the other thing is that I'm trying to think of what else I should involve. To let you guys understand what you should guys expect when you're doing these equations. The other thing that you should know is that some sequences they also they don't even involve, it doesn't have to be 5, 6, 7, 8. It can also be like 2, 4, 6, 8. Like you know how you're like multiplication, like it's linear, right? Like 2 times 2 is 4, 4 times 2, 4 times 2 is 8, you know, all of those things that just make sense, and they just goes on whole sequences, you know, all that, like yeah. So like 3, 6, 9, 12, all those things, and I think that's pretty much it for what I'm talking about at this moment. But I'm gonna just give you like a short review. This is like a short part review, but I was just talking about infinite sequences, and this is also infinite sequences too that I'm talking about. So basically, I'm just trying to give you like a definition, a deep definition of what it actually means. So infinite sequences is a function whose domain is the set of positive integers. Now that means that only in infinite sequences, the functions of the domain is a set of positive numbers. So that means that the domain part of the sequence is always positive. The range would probably be negative, or it can be positive too. I'm not really sure about that, but I'm mostly talking about positive numbers right now for the domain part, because mostly it's gonna be the hard part of the domain. So this one, like A1, A2, A3, A4 is basically the terms of the sequence. So basically, whenever you see like a number like 1, 2, 3, 4, A1, A2, A3, A4 is basically substituting 1, 2, 3, 4. When you see the equations that I show you guys when I explain the problems, you will see that how I'm substituting A1 to A2, everything like that. Example, if I like A1, I'm substituting an equation, A2, I'm substituting an equation. It's kind of like substituting, you know what I mean? Substitution. Mostly in this topic is substitution, and that's basically all you should know about. And yeah, you know what? Let's get started. Alright, so this is the first question, and this one is talking about an equals to 3n minus 5. So basically, we have to find we have to write the first 5 terms of the sequences. Okay, this is a very step-by-step process, and we're gonna see how you're gonna substitute A1, all these numbers into the equation. Now, the thing is that you see how there's a sequence. There's already a sequence of A's, 1, 2, 3, 4, 5, A5, A4, all that, right? It can also it can also still go if you want to until you want to stop. But for now, since it only have 5 slots, we're only going to be doing 5, okay? Sometimes there will be some questions that will involve more than 5, but the most common that they bring is only 1 through 5. That's all. So basically, we only have to focus on 5 for this one. You don't have to keep on going because it's not going to ask you for A6, A7. It's just only asking you for 1 through 5. Okay, let's get started. So 3n minus 5. Now remember, an is equals to 3n right here, and minus 5. Now you see how these are basically the same thing. They're just saying that the n is also replaced in 3n right here. Now, this means that something is going to be multiplication right here, okay? And you see how a1, now let me just do equal sign so you guys know or don't get confused. So what we're going to do is that we are going to involve. Now, we're going to substitute 1 to n. Now, why? Why do you think we're going to substitute 1 to n? Well, because if you think about it, a1 is equal to a1, a2, a3, and so on. You see how over here it has 1 through 5? Now, an is basically substituting a1, a2, a3, a4, a5. Simple as that. Just think about it like that, okay? So let's get started. Okay, so 3 times by 1 minus 5. Well, obviously 1 is positive, so 3 minus 5 will be negative 2, right? Negative 2 right there. 2. 3, 2 minus 5. 6 minus 5 is equal to 1. There's no negative. 3, so that means that 3 times by 3 minus 5 equals, well, 9 minus 5 is equal to 4. A4, 3 times by 4 minus 5. Sorry about that. My camera just cut off. But, so basically 12 minus 5 is equal to, well, 7, because 7 plus 5 is equal to 12. Okay, so 3 times by 5 minus 5. Oops, that's... Okay, so this is the last term, right? So 3 times 5 is 15, so the 15 minus 5 is equal to 10. Now, you see how it's going least to greatest in this sequence. Most of the time, it could be going by greatest to least, and yeah, it doesn't always have to be least to greatest. It can also be greatest to least. But in this situation, in this case, it's going greatest to least. So you see, it's gonna go down. Well, actually, sorry, my bad. I'm just saying that this is kind of hard to explain it on, you know. Oopsies, I'm ruining everything on here. Basically, it's kind of going up, I guess you could say. Okay, like over here it'll be greatest to least, and over here it's like basically like up and down. You know what I mean? Okay, so now the sequence would be negative 2, 1, 4, 7, and 10. That would be the sequence for this problem. Okay, so this is problem number 2. Now this one might be like, okay, what the heck is this? Well, it's not that confusing. Calm down. It's just saying that basically since there's no like sequence of numbers, there's no like A1, A2, A3, A4, or whatever. We're only gonna be focusing on A10 now. Only A10, nothing else, because we're only asking for A10, right? Most of the time it would be asking for like greater, like A11, A12, A13, or you know, A5, A6, A7, whatever. But for this case, we're only going to be focusing on A10, okay, the term 10, okay. Now in this problem, there's a lot of n's here. You can see how there's n minus 1 over here and n parentheses n minus 2. It's a lot of substitution, but it's going to be very easy when you're done solving. So let's start with the substitution. The first step is to look at how many n's there are. You see how an, remember what I told you before, an is equal to a10, right? Because basically replacing n to 10. You see right there? It's basically replacing n and 10, right? So that means that the 10 will also be substituting n minus, like 10 minus 1, 10, 10 minus 2, like that. So you see how there's 3 n's right here. So how are we going to substitute? Well, we're going to substitute with the n. So negative 1 times by 10 minus 1. Now in this situation, you will have to subtract 10 minus 1 because you're basically subtracting, right? Most of the time there will be no subtraction or addition on here. It would just be like that. It would just be like this without the subtraction or addition. But most of the time it would be subtraction and addition too. So remember that. You always have to subtract, okay? Most of the time people forget, even me too. I always forget too, but when you get used to it, you will see that, okay, well, we have to subtract it first, and then we're going to see how it goes, okay? Because if you don't subtract it, you will automatically get it wrong. Automatically. Now, brackets with n, which was 10, times by 10 minus 2. Now, let's see what we have here, okay? In this situation, we see that negative 1 is, okay, so negative 1, 10 minus 1 is 9. Let's try simplifying, okay? Step by step. So brackets by, now 10 times 10 is 100. So now we're going to be distributing. So 10 times 10 is 100. 10 times 2, or 10 times negative 2 is minus 20. Now, let's do it again. So we see that negative 1 times 9 right here. So 100 minus 20 is 80. And then you're going to start simplifying again. So 80 times negative 1 be, okay, negative 1 by 9 is what? Well, if you think about it, negative 1 times by negative 1, negative 1, negative 1, negative 1, keep on going until 9, it would basically be turned into negative 1, okay? If it was like negative 1 squared, it would be 1 because you're basically multiplying them together, making it positive 1. But when you're multiplying over and over again until it reaches 9 negative 1s, you will see that it's going to be turned to negative 1, okay? So it's basically negative 1. Okay, I'm not going to do that. Now, 80 times negative 1 is negative 80, right? So that's basically your answer for this problem. It's just step by step, you know, just remember that you just have to substitute n and just keep solving all the way through, okay? Okay, so this is the third problem, and this problem involves sequences. Now, it was involving sequence before too, but in this situation, the sequences is the question to answer. Now, this might be a little confusing to everyone most people get confused because they're just like, okay, how are we gonna solve if there's nothing, if there's n, you know, and there's no n in the sequence, so how are we supposed to do that? They just like leave it like that. It's like, okay, what do we do? Because there's no n, right? Well, in this problem, they're actually asking you to write an expression. They're actually asking you to find a formula or an equation that will substitute these numbers to the n in the equation. You see how in other previous question we were doing, they already had an equation, so we can substitute the terms in the n, right? In this problem, this is the answer of the sequence. Like, you know how in the previous questions we had to find the sequence, we had to find the answers of the terms to make a sequence. But in this problem, they already have the answers of the sequence, but it's gonna be reversed. It's gonna be like an opposite way of how to, like, it's gonna be like a reverse, okay? We're just basically reversing of the steps. So they already have the answer here. They already have the sequence answer, but now we have to find the equation that matches the sequence. And then when we find the equation, we're gonna have to check to see if it actually makes sense or not, right? So, oh my gosh, okay. So an. Now you see, the first step is to identify what makes these terms similar together. Just ask yourself, is it addition, multiplication, subtraction, division? What is it? It's not fraction, because it's not a fraction, obviously. You can see right here. Oopsies. It's numbers. It's whole numbers. So we have to find out what makes them so alike that would make sense in an equation. Well, you see here how this one is 2. These are all times by 2. The linear is basically 2. It's going linear, right? And a graph will be going linear. So since all of them are basically multiplied by 2, because 2 times 2 is 4, 4 times 2, or sorry, this is addition, my bad. So it's like 0 plus 2 is 2, 2 plus 2 is 4, 4 plus 2 is 6, so on, so on, so on. Okay, so now the confusing question to ask is, how are we going to make an equation that would make sense, that would substitute n to the sequences of the terms? Now, that's a very, very, very complicated question to answer. First of all, think about how n is equal to 1, 2, 3, 4, and 5. Now this is what I do. I first of all mention that 1, 2, 3. Now n is basically equal to 1, 2, 3, 4, 5, so on until n, right? and whatever stops by n, right? And the terms we have at the moment is, well, let's see. Terms are 0, 2, 4, 6, 8, 10, and 12. These are the terms we are actually dealing with right now, but this is the terms that are actually the form. This is like a start of how it goes, you know. Now the pattern we see right here is that you can kind of see how it's kind of going less by, like, you see how the difference between these two. Just ignore these two. This is just an extra one I just added just in case, you know, just to make it sense more. But or let's just add it here so you guys know what I'm talking about. 6 and 7, okay, and then so on. So you see how there are differences in this problem. Now, why do I see differences? Look at the pattern. You see how it's kind of like going by -2. It's going less than 2 times. You know what I mean? So now when you're doing this problem, you will see, okay, so each term we have is 2 less than 2 times. You see how it's like in the difference between them, like 2 less than 2 times, right? 2 times n. So then it basically goes into the equation of let's say. So if you think about it, it'd be 2n because it's the term are 2 less than 2 times n. So that means that it'll be 2n minus 2. That would basically be the answer. Now, if you want to check, you can always check by substituting the sequence to the end, right? Remember, we did the last time like a reverse. So 2 times by 2 minus 2. Well, 4 minus 2 is equal to 2. You see how it just keeps on going like that? So like 2 times by 4 minus 2. So 8 minus 2 is what? 6. So it just keeps on giving you problems that just keeps on leading. You know what I mean? It just starts like in the sequence. Now you can also check more. You can check the whole thing if you want to. Doesn't matter. But mostly I would just check at least like three numbers to see if it would make sense or not. But in this situation, this is how you solve. And yeah. Okay, so this is this is actually the fourth problem. Very much sorry about that. I forgot to remove that right here. Fourth problem. Okay, so in this problem, we're going to be talking about the sum. Now, to find the sum. Now, this is actually very, very common in Algebra 2. Basically, it's okay. Let me just give you a review of how are you gonna solve it by finding the answer. Now, the thing is that this J part, so J is actually okay. Sorry, I have no idea how to explain this, but basically 6 is how much you need. Now, for example, okay, so basically you're gonna have to find 4 through 6. So you see how the sequence is 4, 5, 6, right? It's gonna go 4, 5, 6, and then you're done. If it's at 5, you would just do 4 and 5. Okay, that's all. So basically you're gonna be starting with 4 and then ending with 6. Example, if J was 7 and this was like 12, you're gonna be 7, 8, 9, 10, 11, 12. There's like 5 terms, right? But in this situation, it's only 4 to 6, so it's 4, 5, 6. So we're only gonna have 3 terms in here, okay? Only 3. But I'm just like giving a review of how it goes and how you're gonna solve it in this in this problem. So basically, we have to find the sum of this whole thing, okay? Now this is a step-by-step process, okay? But if you do step by step, it's gonna make more sense and easier for you to understand in other problems that are more complex. Now, let's see what we have here. So 4 to 6. Now there's 4, 5, 6, 3 terms, right? Okay, so now this is where this problem, I guess you could say setup, is basically how we're gonna replace. So basically J, okay, just think of how J is N, okay? N, J, H, whatever is basically all the alphabets that we have to substitute by, right? Now J, you see how J equals 4 right here, right? That means that the J we're gonna have to be here is gonna be 4, 5, and 6 until we end 6, right? Until we reach 6. So when I show you guys how to do step by step, you will see what I'm talking about. Talking about it doesn't really make sense to you guys because you're just like, okay, can you like, what? How does it make sense, you know? But when I show you guys how to do it, you will see it physically of how I'm trying to find the answer. Okay, so this is 1 over j squared minus 2. That means that we're gonna mostly be using this in order to find the sum of the whole thing. Okay, so let's use this as the key to finding the answer. Okay, so let's see what we can do here. Now let's find the answers of 4, 5, and 6 in each ones. Okay, and then we're gonna add them together and then find the sum. Now 1 over 4 squared. Now you see how I'm replacing 4. I'm starting by 4 and then I'm gonna end with 6. Okay, 1 over 4 squared minus 2 is actually equal to 1 over 14 because 16 minus 2 is basically 14, so 1 over 14. Okay, 1 over 5. Now you see how I'm going by sequence, 4, 5, 6. Okay, so 5 squared minus 2, so 25 minus 2 is what? 23, right? So 1 over 23. 1 over 6. Now this is the last number. Don't go any more forward. Just end with 6, okay? Because this top number is telling you to end with 6, not to go forward. Just end it with 6, and you're all good, okay? 1 over 6 squared minus 2, so that means 36 minus 2 is 34, I'm guessing. So 134. Now, we're not done yet because this is not the sum. Sum is meaning the whole answer, right? Now, if you think about it, when you're adding them together, so let's add them together, okay? Let's add this all together. Now, 1 over 14 plus 1 over 23rd plus 1 over 34. Now, I would usually usually solve it by just, in paper or something. But for now, in this problem, I don't have that much room. But you can also solve it in the calculator if you want to. In a calculator, the answer would actually be 395 over 2737. Now, this is the answer of the whole sum. So you see, we only have to do like what? The first step, and then the second step was to add, and then you got the answer. Okay? So this is the sum of this problem, and